So welcome back to my channel guys. Hope you are doing extremely well. It's a day 22 of solving the GFG POTDs and it has been a long journey. Okay, so today's problem is Techfest and the Q. Let's see what does the problem say. The problem says that an college is organizing a Techfest. I'm sure your college also organizes a Techfest for you. And there is a queue behind. There is a queue for it. There is a queue for it. Each person receives a ticket with a unique ticket ID. Okay. The ticket ID starts from 1 and goes up to the person who is achieving it, that is n. Okay. Now, the organizers of the tech fest decided that the persons with ticket IDs and in the range A to B will be awarded prizes. Okay. Suppose there was a total 100 guests, so the ticket numbers would be 1, 2, up till 100. The organizer said that we will be awarding prizes to the persons who have ticket IDs in the range, let's say 34 to 63. All right. Now we have to include 34 and include 33. Keep in mind. Okay. Now, what will be the amount of the prizes? The amount of the prizes. This is the main question here. The amount of the prizes would be sum of powers of prime factorization of those numbers. That is, suppose the ticket ID is suppose the ticket ID is 40. Okay, let's do the prime factorization of 40. So 40 would become divided by 2 become 20, divided by 2 again becomes 10, divided by 2 again becomes 5, and divided by 5 becomes 1. So the 40 can be represented as 2 cube into 5, right? So the amount would be 3, and 5 can be represented 5 to the power 1. So the answer would be 3 plus 1 equals to 4. The amount of prize that would be given to the person at ticket number 40 is 4. Okay. What do we have to output? Our output would be total cash money organizer have to spend in prizes. Organizer have to spend in prizes. That is, if the range was 34 to 63, we have to calculate the price of each person that is in the given range and add them up and return the sum and return sum. I hope the problem is clear to you. You know what we have to do the output and what do we have as an input. All right, for input we just get a and b. Okay, for input we just get a and b. A and b are the indexes of a ticket from which we have to take. The 34 here is a, 63 is b in the given example. All right, I think I made my point clear. Okay, so how do we have to approach it? Okay, let us come to the brute force approach. The brute force approach. The brute force approach that should be clear in your mind should be that from A till B, calculate prices individually and add them up. Correct? Like take A, calculate the prime factors, calculate the sum of the prime factors and add it to the answer. Then go for A plus 1 and repeat the same up till B and repeat the and return the sum. Right? What would the time complexity? The time complexity of this type of approach would depend on how you are taking the prime factors. How you are taking the prime factors is, The formula for taking the prime factors would be that if your I is less than equals to 1, for that case return 0, because I'm taking them as I. First the I would be this, then this, apple, then this. If your I is less than equals to 1, you return 0. Why return 0? It is pretty evident that 1 is not a prime number, and no, there is not a prime number below 1, right? And the elements less than equals to 0 do not have a prime number. I think you know that basic maths, okay? Now, what can we do? Now for int I ranging from 2 up till root n, root n, what can we do? Count equals to 0 right now, okay? Now while n percentile I equals to 0, count plus plus, and n will become n by I, okay? After that, for 2, the this loop should come like 2, then 3, then 5. That 2 is the only even number. Then we have to go to 3, then 5, then 7, and all the odd numbers up till root n, including root n, actually including root n, okay? If it is a square root, square, perfect square. Okay, now if after all the four loops, if I have a number in hand, if if n is greater than 2, that means n was itself a prime number, and the factor remained in our hand is itself a prime number. For that, count plus plus. Okay, this would give us a prime factorization sum, all the sum of the prime factorization for the given number. Okay, I think you got it. Let me try run this for you. Okay, suppose your number is 10. Okay, what I'm saying is it fails the base condition, so it comes here, right? Our I is initially 2. All right, it will go up till 3. Yeah, only 3, because 5 and 5 into 5 is 25, which is greater than 10. Okay, so 2 and 3. Okay, count, my initial count is 0. All right, now while n percentile I equal to 0 means 10 divided by 2 is equal to 0. Yes, 10 is divisible by 2, so count plus plus, count becomes 1, n equals to n by I, so 10 becomes 5. Okay, moving to 3, because 5 is not divisible by 2 now. Moving to 3, I will see that 5 divided by 3 is not equal to 0. So this step will not be executed for 3. And I plus plus, and we will exit the loop. Now, if n is greater than 2, yeah, 5 is greater than 2, right? So count plus plus. So it will become 2. And if you check, 10 is written as 2 into 5 to 1, 1. It becomes 1 plus 1 equals to 2. Yeah, our program runs fine. We have a output match. This is very easy to understand. I don't think there is any complication that you're going to understand right here. Okay, let's move into the time complexity analysis. The time complexity. Let me change this here. Time complexity. I think the pen has not changed. Yeah, time complexity and the space complexity. Space complexity, it is pretty evident. We are not using an express space, so it will be over. Correct. The time complexity. The time complexity, if you observe, it will take b minus a times. Correct. And for each number we are running root n times. Okay, so what can be the time complexity if we combine that? It can be in worst case b root b, correct, because b is the largest one. So the time complexity becomes O of b minus a multiplied by root b. Okay, I hope the analysis is clear to you. All right, let us code it down first. It is an inefficient approach. It is a inefficient approach, right? But I don't know why the test cases given on GFG are running fine for this one also. Okay, so let us code it down, but stay with me because I will tell you the perfect approach for it. I will also tell you the optimized approach for it, and that matters in the interview, nothing else. Okay, you have to go through brute force, then if there is an efficient solution, then through that, and at last, at the very last, you should show that I have thought of optimized. You should not project that I already know optimize. In that case, they will think you as a crammer. Okay, it has happened with me. That is why I'm advising you. Okay, so go through the brute. If there is a efficient, go through that, and then at last tell them the optimize. Okay, and in between, keep asking them the edge cases, etc. Okay, very important. This is a very important tactic for an interview. Please understand. Okay, so let us go down the brute force approach real fast. Coming to the code, how will we approach it? Yeah. What did we say? We say keep and counter for answer. Int answer equals to 0, right? Now, for int I going from A up till and including B, I plus plus, okay. And then answer plus equals to, let me name that function solve the ith value, and at last return answer. This is the driver code. Okay, we have to just implement the solve as we saw in the brute force approach, which I explained in the pseudo code. Okay, it will return an int. So int solve. Let me take it as n. Okay, what was the base condition? That if n is less than equals to 1, return 0. Also, if n equals to 2 or n equals to 3, in that case return 1. Correct. These are the base cases. No need to write. Okay. Now the main question arises. Int answer equals to 0 right now. Now for int I going from 2 till I into I is less than equals to n. Sorry, this is, yeah, I into I is less than equals to n I plus plus. Our first step was to check if it is 2 or an odd number. For every other value, discard this loop. If I equals to 2 or I percentile 2 equals to 1, in that case only it will run. What we were doing, let me name it as, yeah, while n percentile I equal to 0, answer plus plus, okay, and then answer would become, sorry, n would become n by I. Correct. Okay, this is a loop, and at last return your final count. I hope the code works. Okay, I don't think I've missed anything. No, running fine. There has been a mistake. Yeah, the mistake is we didn't actually include that if n is greater than 2. That if n is greater than 2, in that case count, sorry, answer plus plus. Okay, compile and run it. Hope it works now. Working fine. Let's try it for submit also. I'm pretty sure that it will output good. Yeah. So it was a successful attempt, but I'm saying that this is still an inefficient approach. Let me show you the optimized approach. Please stay with me, okay? Okay. So coming down to the optimized approach. In the brute force approach, we were calculating the prime factorization for all of them. Okay. What if we have prime factorization in hand for all of them? Prime factorization in hand. How is it possible? I'm saying create a table, create an array, sorry, create an array for all the numbers you have. Suppose the given range for you to you was 9 to 12. Okay. I say create an array for all the 12 indices. That is, this will be 12th index, this will be 11th, 10th, 9th, 8th, 7th, 6th, 5th, 4th, 3rd, 2nd, and then first index and zero index. Now, what will this vector store? Let me name it as V. Okay, V. Let's change the color. Yeah, V will store the smallest prime factor corresponding to each number. What will we store? We will store the smallest prime factor. Smallest prime factor. What is the smallest prime factor? Let me name that 12 can be factorized into 4 into 3. This can be factorized into 2 square into 3, right? So 2 and 3 are both the prime factors for the 12, and 2 is the smallest one. So 12 will contain 2. Similarly, 11 is the prime number, so 11 will contain 11 only. 10 is 2 into 5, 2. 9 is 3 into 3, 3. 8 is 2 into 2 into 2, it will contain 2. 7 is already a prime number of 7 here. 6 is 2 into 3, so 2. 5 is uh, prime number, so 5. 4 is 2 into 2, so 2. 3 is prime number, so 3. 2 is prime number, so 2. 1 is, what can I say? 1 is not a prime number neither. So 1 will store 1 only, let's say 1. And 0 is 0 will store 0. Okay. These two numbers are not for importance. Okay. Now what can we do? We have to make this table in the least time possible. How can we do that? The algorithm that I suggest you is for I starting from 2, starting from this index, going up till last index, that is 12 here. What you can do, if initially fill up this array with minus 1, okay? Minus 1, 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 minus 1. I am filling it with minus 1 to show it as this index has not been visited earlier. Okay. Now if v of I is not equals to minus 1, that means this index has not been visited earlier. Now for a number, if it has been not been visited earlier, like we say that 11, okay, if a number from 1 to 10, so sorry, from 2 to 10 was not able to divide 11, so 11 is the smallest prime factor of itself, correct? Repeating, if any number from 2 to 10 is not able to divide 11, then 11 is the smallest prime factor of itself, correct? Okay. So if vi is not equals to minus 1, that means there was not any number in the range 2 to that number minus 1 that could divide it perfectly. So vi will be equals to y, that is the smallest prime factor for itself. Now for the every multiple of this I, for every multiple of this I, it is the smallest factor, smallest prime factor for that, that is for int x starting from I, x less than, that is 12, less than equals to 12, that is size of the what can we say, size of the vector v, x plus equals to y, v of x equals to I. This is I'm saying. You can check also. For 2, it was 2. For 4, it was 2. For 6, it was 2. For 8, it was 2. For 10, it was 2. For 12, it was 2. For 3, it was 3. For 6, it is 2 because it has already been visited by 2. Okay. 3, then 9. 9 is for 3. Okay. Similarly, for 4, it has already been visited by 2. We cannot do it for 2. Now 5. 5, then 10 is already visited by 2, so no changes. Then 7, then 11. Okay. I think I have made a clear point in your heads. Correct. By using this loop, we will get this table filled up. Okay, this is the loop to fill up the prerequisite. Are we on the same page, guys? Are we on the same page? If yes, please hit the like button. Okay, now how can we process it? Yeah, so now we have this table in our hands. Okay, how can we use it? I'm saying initialize your answer as 0 currently. Now for I going from a up till p, this is a range. Okay, b is included in it. Okay, just keep in mind. Now while I while I is greater than 1, while I is greater than 1. What you have to do? You have to count plus plus. Okay. Sorry, this is answer plus plus. We have stored our answer. Okay. I am just confusing myself with answer and count. The thing is same. Answer plus plus, and then I will change to I by V of I. Don't be shocked, don't be shocked. I will tell you how is it happening. Okay. Suppose we have got 12. 12 can be written as 2 into 2 into 3. So it should return 3 as your answer, correct. Let us run it for 12. We have got 12 in our hand. Okay, answer is currently 0. Okay. 12 divided by 2 becomes 6. Answer plus plus. Okay. Coming to 6. 6 divided by 2 is 3. 3. Answer plus plus 2. 3. So 3 divided by 3 gives us 1. Answer plus plus 3. While I is greater than 1, it is written. Okay. So the loop will exit and we have 3 as our answer from 12. Working fine. Alright. Just try to think, why is it working fine? Is it doing the same thing we were doing in the prime factorization? Yes, it is doing the same thing we were doing in the prime factorization. Okay. Because 2 into 2 into 3, so it should be divisible by 2 times. So 12 divided by 2 gives 6, which is also divisible by 2, smallest prime factor. So 2 is coming 2 times and 3 is coming only 1 time, so we have got 3 as our answer. In If we think of it peculiarly, it is a better approach, since we can find the prime factorization also. We do not have to count only the numbers of prime factors. Okay, we can find the exact configuration also. I think I have made my point clear. Okay, the time complexity analysis is, we have used the space of B. Sorry, yes, this is the space complexity of B, correct? Okay. Now this will run for B minus A times, and this will run for log B times. Log n times, log I times in the sense, but that is in worst case is B, and I can also make it as B, so it will be log B log, which is way more efficient than what we discovered previously in the brute force approach. Let us just code it down and end the video, because it has been a long video up till now. Let me reset the previous code. Yeah. So our first step was to create the, let me zoom it down. Yeah, create the prerequisite table. How we were creating it? We were initializing a vector int, name it v, and then size would be of b plus 1, because we need an index of b also, so b plus 1 would be the size of the array. Initialize it is 1, so v of 0 will become equals to 0 and v of 1 will become equals to 1. Okay, clear up till now. Now for int I, starting from 2 going up till equals to b I plus plus, if vi equals to minus 1, that is, this has been remained unvisited. In that case, fill all the multiples with the same I. Now for int x starting from I, x less than equals to b, x plus plus, v of x will become I. X plus plus, sorry, no, x plus equals to I. Okay, multiples, right? Got the table right now? Okay, now proceeding towards the solution. Our answer is currently 0 for int I going from A up till B I plus plus. Okay. Now int x equals to A. Let me store it in. Let int x equals to I. Sorry. Now while x is greater than 1, answer would be incremented. Correct. Then answer would become answer by v of x. Okay. Now return your answer. Let's try to compile and run the code. Hope I'm not doing any mistake. I mentioned all the steps. Program took more time than expected. There has been a mistake somewhere. Uh, Answer equals to answer v by v of x. Mm. Sorry, it would be answer plus plus answer x equals to answer by sorry the classical mistake. Sorry to waste your time, guys. Running fine from compile run. Let's try it for submit. Running fine. Thank you for watching my video and keeping and being patient with me. Hope you liked it. Hope you like my approaches. And if you liked it, please don't forget to subscribe and like my video. It means a lot to me. It motivates me a lot. Thank you for watching. Have a nice day.